Today we're going to do lesson 2-3, which is solving multi-step equations. Here we're going to solve the equation, and you always want to check your solution, whether you write it down or whether you check it in your head. So, if I want to solve any equation, I want to look at where the variables are. So in this case, the variable a is on the left side. So I want to get everything away from the a except for the a itself. So I need to cancel out the 6 and I need to cancel out the 2. How I choose which one to cancel out first is which one is directly with the variable and which one is apart from the variable or separated by an operation. So in this case, 2a, 2 is right next to the a, but the minus 6 is separated by the operation minus, so we're going to add the 6 first. And the reason why I'm adding 6 is because subtracting 6 and adding 6 will give you 0. And 0 is what I want because I need to cancel out everything with the variable. So I'm left with 2a, and it's technically plus 0, but we don't need to write that, equals 4 plus 6, or 10. Now I need to go back to the variable side, or where the variable is, and I need to cancel out the 2. So I think about 2 times a is what this means. So to cancel out the 2, or make it into a 1 is what I need to do the opposite operation, which is to divide by 2. So that cancels out the 2. It becomes a 1. I don't need to write 1a, I can just write a. The 1 is assumed. So 10 over 2, or 10 divided by 2, is 5. And that would be my answer. Now if I were to check, I'd just plug it back into a and see if one side equals the other, which 2 times 5 would be 10. 10 minus 6 is 4, so that would be correct. Now we're going to solve this equation. Here you have n plus 1. Well, n plus 1 is together as the numerator. So whenever I have the variable as the numerator, I want to cancel out what's with the denominator first. So n plus 1 divided by negative 2 is what this says. If I'm going to cancel out the negative 2, I need to multiply by negative 2. And whatever I do to one side, I do to the other. So I just multiplied by negative 2. That cancels it out on the side with the variable. I need to bring down what is left, which is just the numerator. And I need to do 15 times negative 2, which gives me negative 30. Then I'm going to go back to the side with the variable, and I need to cancel out the 1. The 1 is plus 1, so I'm going to subtract 1. And then I would have n equals negative 30 minus 1, which gives me negative 31. For this word problem, we're going to try to come up with an equation first and then solve. So we need to look for keywords in this problem to help us come up with our equation. So we're starting with a music store has sold 3/5 of their hip-hop CDs. So the word of stands out to me. Same with a number always stands out to me. So 3/5 of. That's getting me thinking that that's going to be 3/5 times something. And then it says something about hip-hop CDs. So if you keep reading, it's asking at the end how many were there originally. So how many CDs? So CDs is what we don't know, or the hip-hop CDs is what we don't know. So we usually put that as a variable. So far, in the first part of the sentence, I have 3/5 times, let's say, H for hip-hop CDs. Then it says 10 were returned. So if they've sold 3/5 of their hip-hop CDs, but 10 were returned, we would need to have to subtract those 10 from what they sold because they were returned. Okay, so we would need to set it up as 3/5 of, so 3/5 times h minus 10, based on that part of the sentence. Now the store, oops, I repeated that. So then it says, now the store has 62 hip-hop CDs. So that is what they have now. So if they have 62, that's going to be our total, which is always what you equal the equation to. So on the next page, I'm going to write it out. 3/5 of all the hip-hop CDs were sold, but 10 were returned. So that's not going to count towards what's sold. Now they have 62 left over. So this would be my equation. If I were to solve this, again, I look on the side with the variable. I'm going to cancel out the 10 first because the 3/5 is right next to the h, so that's directly with the variable. I want to cancel out what's not directly with the variable. It's a minus 10, so I'm going to add 10. I bring down what's left, which is just the 3/5 h, and that's equal to 72. And then I need to solve for h, so I need to cancel out the 3/5, which would mean I multiply by the reciprocal, or 5/3. And I do that on both sides. Now I have h by itself. When I multiply or I do anything with a fraction, I need to make sure both of them are in fraction form, so I can make 72/1 to put that in fraction form. And then really I could just multiply the numerators, 72 times 5, and then divide by 3. So 72 times 5 is 360. Excuse me, 360 divided by 3 is 120. And that would be my final answer. Now we have another similar problem here. It says Len read 3/4 of a graphic novel over the weekend. So again, we have the 3/4 and we have the of, so 3/4 times. I'm going to look for my variable, and it's talking about how many pages. So we're thinking of pages then in this graphic novel. Okay, so 3/4, let's say p for pages. So 3/4 times p, or 3/4 p. Then it says over the weekend, oh no, he read that over the weekend. Then it says Monday he read 22 more pages. So he read 3/4 of p already. Then he read 22 more. So 22 more, if we're thinking keywords there, that would be plus 22. And then now he's read a total of 220 pages, so that's what we're putting it equal to. So if we do this on the next page, I have 3/4 of the pages in a novel, which we don't know, plus 22 more pages that he read on Monday, and that is equal to our total pages that we have, which is 220. So that would be my setup. Again, I'm looking to get the variable by itself here to solve, so I'm going to have to subtract the 22 first, bring down what I have left over, and 220 minus 22 is 198. And to cancel out a fraction next to the variable, I'm going to do multiplying by its reciprocal on both sides. So I have p by itself. I need to make 198 into a fraction, so 198/1. And then I'm going to multiply my numerators together, so 198 times 4, which is 792. And then I need to divide that by 3, or 3 times 1, which is 3. So 264 would be my answer. The last part is when you're thinking of consecutive numbers. Usually you have a number and then you think of consecutive would be the number after it and then the number after that and then the number after that and so on. So let's represent a consecutive integer with the number, the variable n. So then if I thought of the number after that, it would have to be n plus 1. And then if I keep just thinking of the number in terms of n, the number after n plus 1 would have to be n plus 2, because it's 2 spots, and then it's so on. So that would be how you would create an equation to find consecutive integers. Okay? If you had consecutive even integers, you'd have n, and then you would have n plus 2 to make the next one even, and then n plus 4, and so on. And then that actually would also apply to if you were trying to come up with odd consecutive numbers. So you'd start with n again, and then it would have to be 2 spots from that to be a next odd number, and then so on. Okay, so those would be our 2 setups when we're trying to deal with consecutive integers. So if you look underneath here, we have find 3 consecutive integers with a sum of 21. So let's say our first integer is n. Our next integer would have to be n plus 1 if they're going to be consecutive. And it also says sum, so I'm going to add n plus 1 plus n plus 2. And I know to stop there because it says 3 consecutive integers. And my sum is supposed to equal 21, so I put it equal to 21. Then I'm going to combine like terms, so all the n's. We have 1n, 2n, and 3n. And then we have a 1 and a 2, so that's going to be plus 3 if I combine. And I'm solving for n, so I would need to subtract by 3 to get the n by itself. I have 3n equals 18, and then I divide by 3 because 3 times n, the opposite would be dividing, cancels out, and I have n by itself. So n would be 18 divided by 3, or 6. So n would be 6. So my 3 consecutive integers would be 6, 6 plus 1, or 7, and then 6 plus 2, or 8. So 6, 7, and 8, because I would plug in what I found for n in my equation, and that would give me my integers. And that concludes lesson 2-3.